Today I'm going to show you how can derive the Hamiltonian equations. Okay, we have two sets of Hamiltonian equations. The first one is Q dot, which is symbolized velocity, which is partial derivative of h respect to p, and p dot is equal to negative partial derivative respect of h respect to q. Now, this p symbolizes the momentum, the change of momentum, but q represents the velocity. Okay, now without further ado, let's start first through the gender transformation. We know that this h is equal to t plus v, where this is Hamiltonian, this is the kinetic energy, this is potential energy. For Lagrange, we take t minus v. Can you see? The system of simultaneous equations. Now let's solve now. Let's solve simultaneously. You can cancel this. If we take h plus c, L is equal to 2t, and then you can see we know that kinetic energy T, which is equal to it is 1 over 2 m v 1 over m v dot v, which is equal to 1 over 2 m v square, and you know that momentum is equal to m v, so T is equal to 1 over 2 times p times v. On my side, V, I can symbolize it like V, let's symbolize it like Q dot, so that we can have 2T, which is equal to P dot P, Q dot. Now let's substitute from here. I can get H plus L, which is equal to P, Q dot. So you can see, let's make such formula for Lagrange, which is equal to P, Q dot minus H. Now we get this equation we use the Lagrange transformation. Using the general transformation, now we arrive on this Lagrange equation. Let's use this Lagrange equation also to arrive on these equations. Now we can start using action. You know the principal action. Okay, where action, which is equal to integration from T1 up to T2 of Lagrange then dt, which says that among all paths for dynamic system, the only actual path allowed is the one that minimizes the time interval of Lagrange or the difference between kinetic energy and potential energies. Now, let's substitute from Lagrange, where S is equal to integration from T1 up to T2. Let's substitute from value of this is P Q dot minus H then D dt. This is now the equation we have. Okay, from there we have action, which is equal to integration of T1 up to T of P Q dot minus H D dt. And then we know that let's find what we call a small variations, where for Q will. Okay, now after getting into small variation for both Q and P, now let's take a look on boundary conditions. Where we know that at one condition, at the end and at the starting point and end point, there's nothing changed. That's why here we have f of t1 is equal to f of t2, which is equal to 0. And then let's take a look on what we call variation in action, which is equal to variation in intervention from one of that value p2 dot then minus h then dt. You can see. Now let's write variation from T2 of variation in p2 dot minus variation in h brackets dt. This is equal to integration from T2 of variation. It writes p variation in q dot plus q dot variation in p then minus let's write partial derivative of h respect to q then q dot then minus partial of h respect to p then can see
P dot.
then p dot then what next? I think you are all done. Yes, then you close bracket like this, then dt. Okay? Now let's take a look. After getting that variation in action, which is equal to the variation of variation, take p, variation in q dot plus q dot, variation in p, then minus partial of h is equal to q, but I found that there is no variation in q corresponding to theta, then minus partial of h is equal to p, which corresponds to this epsilon, like this one, then dt. Then let's variation in p, yes, variation in let's say p, let b theta, and the variation in q b. This variation of take a p, this theta dot p minus q dot times theta, I mean epsilon minus partial of h is equal to q theta minus partial of h is equal to p, then epsilon, like dt. What remains? You can see remain with it. Let's take a look at this factor. Let's take this factor p, integration of p2 dt. Now let's use integration by parts. By saying that let u be p, then it find du is equal to p dot dt, and let also find dv, which is equal to theta dot then dt, integrating both sides, integrating is equal to that is theta. Then let's substitute this integration from 2 up to of theta dot p dt, which is equal to that is u, that is p from the 2 up to then minus integration of 2 up to of v du, that is p dt. Remember, for boundary condition, I found that there is nothing changed for end and start point. That's why this is equal to 0. So remaining is 1 with this guy. And this integration from T1 up to T2, theta dot p dt, which is equal to 2. You eta p dot. Now let's substitute it from where? From this equation. It goes star 1 from the equation star 1. Then we now substitute that variation in action is equal to integrate from T1 to T2 of you can see we get this guy is negative of eta. It is eta p dot, yes, p dot, eta p dot, yes, then minus epsilon q dot, yes, like this, minus part of h expected to q eta, then minus part of h expected to p epsilon, like this dt. Now let's rearrange this equation and say that direct reaction which is equal to integration from T1 up to T2 of, let's combine this guy. Yes, let's factorize negative out, negative p dot, then plus part of h is expected to q, then you can see that eta, and this, yes. This value must have positive because this product will have, you see, this is positive, another mistake date, this is positive, yes, that's why here may having plus of 2 dots like this, minus part of h expected to p. But factorizing this epsilon, you can see how like this, and then you have like this. This is the must we give a minimum of that's why here I have is 0 according to the principle of this action, which is equal to integration from T1 up to T2 of, you can see you have a negative. Here I have negative of p dot plus part of h expected to q eta plus q dot dt. Those constants, this delta and epsilon, they are different from 0 between the parts. They are different from 0 and between the past, and this also they can be equal to 0 at the boundary. So in order to be equal to 0, we must have this factor negative p plus part of h respected to q. They must be equal to 0. Sorry. Must be equal to 0, and even this factor must be equal to 0 simultaneously. They must be equal to 0 minus part of h is equal to p, which is equal to 0. But here we have lost, yes, this is dot. As you can see, this will give this, yes, negative is there and equal to 0, then the p dot will be equal to, you can see negative part of h is expected to q, and this q dot will be equal to plus part of h is expected to p. Those are Hamiltonian equations. Now let's refer if those equations are the ones which are started with, yes. Okay, after writing here, you can see those are final equations for Hamiltonian. Now let's check whether they are the same with those we started with. You can see, yeah, sure, they are as proved. Now, thank you for watching.
Remember to subscribe, like, and share.